Who is the Azure Zurich user group? It's basically me, Manuel Meyer. I'm the main organizer. The user group is the largest Microsoft technology group in Switzerland that I know of. And I think it really is the largest. So if you have any feedback, you can find me at manuelmeyer.net or at info@azurezurichusergroup.com. What's the purpose of the user group? It has been founded about 3 years ago. The idea is just to speak about Azure and learn from each other and get to know new people. Get to knowing new people is kind of hard in this virtual setup, so I'm looking forward for next year to meet all of you guys. And in the end, we'd like to build a strong Azure community in Switzerland. I'd like to show you a couple of upcoming events. The next one is on November 26th. By the Azure Burn user group, where the guy who created Discover.Swiss, an open API platform about Switzerland, created this platform on Azure, and he will show us what he did and the technologies he used and share his experience. Now, for the Azure Zurich user group, in the morning today, when I was in the car, it came to my mind that this session today could just be the start of a full series about infrastructure as code. So I'm currently working on this. Be prepared to see some other sessions about how to do infrastructure as code with Azure Devops, obviously, about ARM templates, Terraform, and domain-specific languages such as Farmer, Bicep, and so on. That's what I'm currently working on. You will find all the meetups on our meetup website, azurezurichusergroup.com. So there are a couple of other user groups that I know of in Switzerland, such as the Azure AI Basel group, the Cognitive and Plot user group, and the Azure Professional group. If there are any other user groups that you know of, please let me know. Feel free to check these guys out. They all have great content as well. But these times where we all mostly stay at home and don't travel too much, why not take the chance and go international? So I have a list of links that you can use to find worldwide Azure meetups, worldwide cloud computing user groups, and worldwide Microsoft technology user groups on Meetup, which is a really cool platform. And they are all free. You can join all of them and see what they are up to. You will get the slides that I'm showing now in the end, but in the meantime, I'm going to copy all the links into the chat. So if you want to use a link, you can do that in the chat. So what else? That's it from my side. I would ask Manuel to share his screen and start the presentation. I hope you have a good session, all of you, and I'll quickly speak to you after the session.
Hello, everyone. Can you see my screen and hear me and see me?
Yes, everything looks good from my side, at least.
Perfect. So thanks, Manuel, for giving me the opportunity to talk here. As he mentioned before, my name is Manuel. If you want to see my Twitter or LinkedIn handle or email, just visit my website, manuel.ziedler.io. And that's already everything I have to tell about myself. So let's switch to the talk. So first things first, this talk is not a theoretical introduction into GitHub Actions or ARM templates. It's really a hands-on only session. So if you need to have some theoretical introductions, this is not the right place, but I'm sure that you will find that interesting anyway. So our main goal today, we want to build a continuous integration and continuous deployment pipeline from scratch, really from scratch, to show you that it's not that hard. And what we want to do, or what we want to achieve, is that we want to avoid right-click publishing and clickety-click deployments in Azure Portal, because it's so easy to do that, but it's for a long way, it's really prone to errors. So that's what we try to avoid here. What's also important is that Azure Resource Manager templates is not the only way to go. There are different infrastructure as code solutions like Terraform or Pulumi, Farmer, and Bicep from Microsoft, which is still in preview. So if you're interested in infrastructure as a code, definitely take a look at the other solutions. All right, so which tools are we gonna use today? We're going to use Visual Studio Code. I also installed the RM tools as an extension, which provides us some syntax highlighting and snippets. Then I'm going to use the Windows Terminal, the Azure CLI, and of course Git. But that's all we need. And I made a checklist for us so we don't forget anything. We have some prerequisites. I have just a sample application, then a GitHub repo that's already prepared. And then what we're going to do is first we're going to take care of the Azure side. So we create a resource group, then the template, service principal to deploy the template, and then we take care of the GitHub actions and the pipelines. And in the end, I can give you a sneak peek into Azure DevOps pipelines. So for all of you who are working with Azure DevOps, I can show you that it's quite similar there to set up a pipeline, and also a short sneak peek into the Bicep TSL from Microsoft. So let's dive in and switch to the terminal. I'm logged into my Azure account. And I have an Azure subscription, so I'm logged in, perfect. Next, we're gonna create a resource group. West Europe is fine. Give it a name. Azure CI/CD Org. Perfect. Then let's go now. We have, as I mentioned before, we have a repository, and the web application is already there. It's just a sample web application, a Razor Pages application. It's not important which one, but it runs. Goes 5001. You can see here, this is the sample web which we're going to deploy to Azure. All right. And as we want to create our Azure resources as code, we also have to create the code actually in our Git repository. That's why under the source folder, I will create a new folder called Azure. So we have Azure and our web application in the same repository. And I will now open that folder in Visual Studio Code. And we're going to create the Azure Resource Manager template first. I call it Azure deploy.json. That's just a convention I always see on the Microsoft doc pages, but the name doesn't really matter. And now we can see, now use the extension I mentioned before. They provide some snippets. So if you type ARM, you have different snippets. Some for a parameter file or for the resource or the template itself. And this will create us the skeleton for ARM template. We have parameters, functions, variables, resources, and outputs. Today, we're just going to use parameters, variables, and resources. We want to create, if we go to the back to the checklist, just to make sure. We have now our resource group. And what are we going to what do we want to build with Azure? First, I did an application insights resource for logging and events and so forth. Then we're going to create the app service plan. which is basically needed to create an app service for the web app, and at least then the app service. So these three resources are the content of our ARM template. So let's take care first of the application insights. There's also a snippet for that, ARM insights. And if we use that snippet, it will create a bunch of different resources like auto scale settings and some actions and so on. So what we really need here is just this one here, components. The other ones are just some extensions which I don't need for our web app. And we have provided a name. What's important is a location, kind, web. That's already good. We don't need any tags. Don't have any dependencies. And it's always good to, if you have to provide a name to a resource, you should create a variable for that, because if you have dependencies between resources and if you have to reference them, you have always take the name, and if you hard code the name and you change it later, yeah, it's like in a real source code. Don't repeat yourself. That's infrastructure as a code. So the same clean code rules apply here. So let's create a new variable. I call it app insights name and Azure CI CD insights. Then I can reference it here with variables and the name of the variable. For the location, that's what I usually do. If I have some Azure projects, I just reference the location from the resource group. So then I'm sure that all resources have the same location inside the group, if you want to have that. And we don't need this one here. So that's already everything for the application insights. And back to the checklist. Next, the app service plan. Also have a snippet for that. Again, create a variable for the name. App service plan name. We'll reference it here. Resource group location, that's pretty fine. Then what's also really important is that in your ARM templates, you usually have some properties or settings that are specific to an environment. For example, here, the SKU of a server farm. SKU basically means the CPU power and how much memory. And that usually depends. So for example, on a test environment, you don't need that much horsepower, and on the production, you maybe want to have lots of more CPUs or memory. So what you then do is, instead of hard coding this SKU here, we will introduce a new parameter called app service plan SKU. Type string is okay, description not needed here, and we will use that parameter. We will see later how we inject the parameter from outside, but the important thing here to remember is everything that is specific to an environment should be specified as a parameter. Otherwise, it gets really messy if you hard code environment-specific settings and properties. So please don't do that. You don't need any tags here. And this is also not needed. And And if I check that, that's already okay for the web server form or the app service plan. So next, we need the app service for our web app. And you don't have to type that all for your own as well, because there is a snippet for web app. Create variable again. Service name. Call it Azure CI/CD app. So there are also some conventions to name the Azure resources. You can find them all on the Microsoft Docs. I always try to stick to them, but you can name them whatever you want to. So again, we will reference the app service name here. The location of the resource group is okay. We don't need any tags. This one is important here. We can create a site without a server form, and it's not given that the Azure Resource Manager will deploy your resources like they are in your file. So it's important, if you have dependencies between resources, you have to use this depends on settings where you can reference another resource. So that means that the website should be created after, or depends on the server form, the app service plan. And as mentioned before, now it's the first time we need this service plan name on another place. So we can use it here. And we have to define the server form ID here again. So maybe if you see, we have referenced the app service plan 2 times. One is for the web app itself, the setting. The web app needs to know what is my server form, or who is my server form I'm running on. And this depends on is really the reference for the template. So the template knows which resources to create first. And we have a second dependency here. We have application insights, and as we will reference the application insight settings in our website, we have to define it as a dependency here. So we use the resource ID function. We have to provide the namespace or the type of the resource. It's Microsoft Insights. And then the app insights name. All right, then we also want to specify the kind of our app service. That's simply an app. And then we have some other, this name is not needed. We have some other properties we can define here. I will copy that because it's a lot of code. So what we also can do is through the RM template is to define the different app settings. That's basically the web config behind. And here we have a lot of settings which concerns the application insights, or at least the reference of the application insights. And that's not something I just know. What I did is, before I worked with ARM templates, I didn't know how to make a connection between your app insights resource and the web app. So I just went to the portal, I clicked it, and then I exported the template, and then I saw what the template looked like. So that's always a way to go if you have some trouble with the ARM templates and you don't find out how to configure something. then it's that's the one good place where you can go to the portal and click your resources and actually look at the export of the template, how it looks like. So that's, in this case, it's really helpful. So you don't have to go from scratch all the time. Maybe you can click your environment and then transfer that into a code, but don't forget that step. Okay, so for example, we have instrumentation key here as a reference, connection string, then some things like the snapshot, debugging snapshot feature. And yeah, that's just, I won't go into details of them, but basically if you want to reference or connect the app insights of your app, you have to set those settings here. Okay, so that looks fine. If we take a look at the checklists, we have now our Azure infrastructure as a code. What is missing is a template for the parameters. As mentioned before, we have, in this case, we have the SKU of the app service plan as a parameter. And for that, I create a new file. I also call it deploy, Azure deploy, and in this case, just parameters.json. In a real-world example, if you have different environments, you would then create something like Azure deploy parameters I don't know, staging.json and so on. So you will create an environment-specific parameter file. But as we don't have just one environment here, I just call it parameters.json. And we also have a snippet for that. It's ARMP. That's a really simple one. And here I just can specify a value for the SKU. And in our case, I will just take the standard one SKU. You can find the different SKUs also on the Microsoft docs. There are a lot of different options. But for demo purposes, I mostly take just the standard one. Okay, back to our checklist. We have a resource group. We have our RM template, which describes our infrastructure as code. We have parameters, and what's now left is a service principal for deployment. For that, we're going to use the Azure Cli. And there is a command. Oh, first, maybe. I have to copy the ID of the user group, of the resource group, which I need later. Okay, so to create a service principal, we can use Azure AD CLI. So we want to create a service principal for role-based access. So what I want to do is I want to create a service principal which just has access to our resource group with the contributor role. And that should be enough to deploy our resources from GitHub Actions. We'll give a name to that principal. Give it a role. And the scope. And that's why I copied the ID. So that means this service principal has the role contributor, but just for this specific scope, which in our case is this resource group. Of course, you can also give scope to a subscription or even on the top level, but we just want to have one deployment service principal for this resource group. So be sure, even if someone or this service principal get leaked or whatever, then the service principal has just contributor access to this resource group. Then there is another handy option here, SDK off. This will when the Azure CLI command runs successfully, it will print a JSON with all the properties and the settings for that service principal, and we can use this JSON one-to-one for the GitHub actions when we create when you create the secret. So let's run this command. Should just take a couple of seconds. And there we go. We have our JSON here. I will copy that for later. Let's go back to our checklist. So on the Azure side, we're complete. We have our resource group, we have our template, we have our parameters, and we have a service principal, which we can later use for the deployment. All right. Now next, we are going to create our GitHub actions and workflows. So first, I mentioned before, for the deployment, we have to create a secret in our GitHub repo, which contains the JSON of the service principal, because the GitHub action will use this service principal to deploy our Azure resources. So here I'm inside our GitHub repository, and under settings, secrets, I will create a new secret called Azure deployment credentials, and I will paste in our JSON. Perfect. So this secret, we can reference that later in our GitHub pipeline, GitHub action pipeline, which we are going to create also in the same repository. So if I go back to the top folder, we have our source folder, which contains everything code specific, our web app, as well as the Azure infrastructure as code. And there is a conventions for GitHub actions. So if you want to use GitHub actions, you have to create a folder called GitHub. And inside there, another folder called workflows. So GitHub will, a convention will search for workflow definitions inside this folder. Yeah. And there,
die halbe Stunde.
I will open that in Visual Studio Code as well, because GitHub action workflows, as well as Azure Devops pipelines, are written in YAML or YML. I don't know what the exact pronunciation is. I just say it YAML. And we need to, if we go to our checklist, we need two workflows. One workflow for our Azure infrastructure that will be a continuous integration. This workflow contains a continuous integration pipeline and a continuous deployment pipeline, and then one GitHub workflow for our web application. And the same here. We want to have one pipeline with for continuous integration and one for continuous deployment. So let's take care first for our Azure infrastructure pipeline. Just create a new file called azure.yaml, and I will switch to that. So we give that a name, defaults Azure. Then we define the triggers first. So this workflow should trigger on every push. And what you also have to define is the path, because we have the web application and the Azure source code, the infrastructure as code in the same repository, and we don't want to trigger the workflow if something changed in the web app, for example. So we really just want to trigger that workflow if something changes at the Azure infrastructure. So we'll give them the paths for Azure. So that's where our RM template is. And of course, the workflow should also trigger if the workflow itself gets changed. So GitHub workflows Azure.yaml. And we also want to define on which branches, which will be for every branch. So that's our trigger. So every push for every branch which contains changes either under source Azure or GitHub workflows Azure YAML will trigger that workflow. Next, we'll define some environment variables. So what, for example, we'll have the Azure resource group, Azure CI/CD RG, if I remember correctly. And we have the template file. Azure deploy JSON and the parameters file. So those environment variables, or we can use those variables later when we define the jobs. Of course, same here, it's code. Think about clean code. We don't want to repeat ourselves. That's why we define some environment variables for things we will use repeatedly in the jobs. Next, we create the first job. So what you want to just think about it. If you have a web application, the first thing you want to do is when you create a continuous deployment or continuous integration, it should compile. What do you want to have to do with our Azure infrastructure as a code? We want to validate the template. So maybe the first thing, if we push changes to our template, it should validate it. And the Azure CLI provides a way to validate the template before deploying it. So we want to do just that here. So I give the job a name like validate. It will run on an Ubuntu machine. And we have some different steps here. For example, it should use a checkout action. It will clone our repository. Then we have to next we have to log into our Azure account. Which will use the Azure login at v2. So that are those are actions that are available on GitHub. This one is from GitHub itself, of course, because it's cloning a repository. Microsoft provides also a lot of different actions on GitHub. Now we're going to use our credentials, which we created before. And can reference them here via secrets, and we called it Azure Deployment Credentials. So first we cloned our repo. Now we're logging to Azure, and next we want to validate it. And you don't have to look at me how I write this whole YAML. So I will copy paste that. So here we're using the Azure CLI action. We call the step validate template, and here's that's basically the Azure CLI command, which some of you maybe already know. We don't create a deployment. We want to validate it. We have to provide the resource group with which references the environment variables, which we defined on top here. You have to provide the template file and the parameters file. And next, what's also really handy, it's still in preview, but it works pretty fine so far, is Microsoft provides a what if command. What you can do is you can use this command, what if, and then it will check the difference, or it will check the difference between your template and the what is actually deployed on your Azure tenant. So you get the difference, and that's really handy sometimes. And I think that's a perfect case for a continuous integration. If you imagine you have to extend your resource template with some new services, and then you create a feature branch and you push it, and then you either first it gets validated, then you can make sure, okay, the syntax is correct, and then you also get some what if outputs to see what will change if we would apply that template now real life. So that's really handy, and we can make sure that that we won't break anything or change something we actually don't want to change. All right. So we have our first job, which is called validate, which in turn will validate the template and make a what if difference. If this job is successful, of course, we want to deploy it. I will copy that here as well. So what's really important here, that the deployment job should only run if the validate job was successful, or the validate job should have been run and it should be successful. And what's also really important is we don't want to deploy every branch. As mentioned before, if you create a new feature branch and add some resources there, we don't want to deploy it. So I usually also check for whether it's the main branch here, and we just want to deploy the main branch. And yeah, if you want to do the deployment on your branch, please talk with your colleagues first. And if you do it, you just can add the branch here, the branch name, and then the deploy job will run as well. So we have the same steps here. We will clone our repo first, then we will log into Azure. And now actually we will deploy the template here, of course. All right, so that's our workflow for our Azure infrastructure. To repeat again, first, for every push on every branch, we will run the validate job. If the validate job was successful, and if it's the main branch, we also deploy our changes. Means we have our continuous integration job and continuous deployment job. Next, we want to take care of our application. So what we're going to do, we will create a new workflow here. I call it web YAML. I'll copy the whole thing here because it's quite similar. Again, here we want just to run this workflow when a change happened under source folder, our web source or the web workflow itself. And we have some environment variables, the build configuration, the folder of the publish output. And now the web name is called the web app name. We can double check that with our ARM templates. Azure CI/CD app, Azure CI/CD app. There we go. Then we have the continuous integration. Continuous integration means in this case just build it. Don't have any unit test here. Shame on me. But of course you would then run the test as well here. But in this case, continuous integration is just .NET build. We just compile it. If the build was successful and if it's on the main branch, then we will actually deploy it. So again, we will call .NET Publish to create the publish package of our web application. We log into Azure, and then we will use the deploy action to deploy our web app. And we just have to provide the name of the app, the name of the web app resource, and the package. Yep, that's all. So now it's time for the special moment. Let's add the resources. We have our workflow for our Azure infrastructure as code. We have a workflow for our web application, and we have our infrastructure code itself. So let's commit. Push. And switch back to our GitHub repository. And now under actions, this will probably be a problem, because now we try to, or it's running the IaC. Perfect. It's running the Azure infrastructure as code first, because if it would run the web first, then this will, no, it's running side by side. Okay, so let's see. Maybe the web workflow will fail because the Azure infrastructure is not ready yet. But let's take a look at the Azure workflow. And you can see that's our trigger on push. It's now running the validate job. Checked out our source codes, logged into Azure. The validation was successful. Now it's running the what if command. And as you can see here, that's the output in green. Or resources to be created. Of course, if you would delete something, we also get some red highlighted stuff. If we delete some resources or change properties of a resource. But this one is really simple because we had no resources yet. So everything is green. So we can see that it will create this insights instance, the app service plan, and the web application. And as the validate job was successful and we are on on the main branch, it now runs the deployment job. So to recap, validate is our continuous integration in this case. and deploy is the continuous deployment. So while this one is running, we can take a look how the web, of course. Build was successful, the web application, and of course the resource CI/CD app does not exist. And that's a good case. It's really important to mention that GitHub Actions is has still some basic features. So actually, it's okay. You can rerun a failed job. That's helpful here. But if you want just to run a new job, there is no button to do that. I can, like in Azure DevOps, you always can run the pipeline, specify the branch. In GitHub Actions, you don't even can manually trigger a workflow. So I'm almost ashamed of it, but if I have to trigger a workflow again, I just create a new commit and run to see if the workflow now is okay. And if it worked, I revert that commit, and that's how I do the manual trigger of a GitHub workflow. All right, so our deployment of the Azure infrastructure is completed. Let's verify that first on the portal. You can see we have our App Insights instance, we have our app service plan, and the web application. And if we browse it, it should still show the default website as our web application deployment failed. In the meantime, if we go here to Application Insights, it should now be linked. Yeah, we can see it here. It's linked to our Insights. It's a link to our Insights instance. And that's the magic of those. If we take a look at those applications inside settings, that's the magic behind it, that it gets linked correctly in the background when we're creating those resources. All right, let's rerun our failed web workflow. Does it run now? Oh, okay. It just started now, the build. So while this one is still running, let's recap what we did. First, what was most important? We created our Azure resources actually as code, and didn't create it over the portal. We extracted environment-specific settings into a parameters file. We created a service principal, which only has contributor rights to this specific resource group to do the deployment on GitHub Actions. Then we created two different workflows, one for our Azure infrastructure and one for our web application. And both workflows contain the continuous integration job and the continuous deployment job. For the Azure side, continuous integration just validates the template and does a what if difference, and the continuous deployment will actually deploy the template. And for the web application, continuous integration will compile the web app, and deployment will deploy it. And it's still running. Should be done in a minute. And it's really, in this case, it's really simple. It's just, it's barely just a web application and nothing else. But now you have a baseline. You already have a working pipeline, almost working pipeline. We will see that in a second. But you have a working pipeline for your Azure infrastructure. So from now on, for example, if you have to add a storage account or other resources, you can always do that on the code level. And the deployment was successful. Let's open that. For example, if I now work on on a new feature, and in this feature I have to store some files in a storage account. Of course, you will first take care of your web application. With the Azure SDK, you will create the code for accessing the storage account. But then instead of running to the portal and create the account there, you just can add the code to the pull request. So then I'll switch back to our Azure ARM template. I will create the storage. Do we need premium? No, we don't need premium. To look up what those are. Azure Storage, ARM. Yeah, standard. Local redundancy is okay here. Mute here. Just give it a name for demo purposes. We won't actually deploy that, but I just want to show you the workflow, how if you have to add some Azure resources. So the real project will now create a new pull request. And what's really neat here is that your pull request contains the changes from your actual code, which is needed for the storage access. But the pull request also contains your infrastructure as a code. So if someone is reviewing your changes, he has the whole picture of your feature. He or she will see the infrastructure changes as well as your code changes. Let me push that. And if we go now back to our actions, you can see that it triggered for our new branch, it triggered a new action or our workflow. And if we configure the workflow correctly, it should just run our continuous integration job, the validation job, and skip the deployment because I'm not in the main branch. And by the way, just to make sure the deployment of our web app worked. Let's close that. And we can wait for the validation and the what if. Validation successful. Now it will run the what if. So perfect. Now I have much more things. Interestingly, it will change also some configs on on our app and our insights. That's very interesting because I just added the storage account. But yeah, that's what I mean. That's what I meant. This what if command is really handy, because otherwise I wouldn't have the idea that this change, just the add of storage account, will change other resources as well. But yeah, okay. You also see that the deployed job was skipped because we checked for the main branch. And now if we create a pull request, that's pretty neat here. If you create a pull request, the reviewer also sees, okay, the validation was successful, the push was skipped. And if you're really interested as a reviewer, you can directly go to the validation job and you can see the what if outputs. So as a reviewer of a pull request, you see everything at a glance, what also changed with our infrastructure, and not just the code from our web app anymore. All right. So we created a pull request to see how this workflow actually is helpful in your day-to-day developer life. And as mentioned in the beginning, a small sneak peek about Azure DevOps pipeline. So if you're working with Azure DevOps and not with GitHub, don't worry. I set up the same demo with Azure DevOps pipelines. I also have one pipeline for the web app and one for Azure. And if you look at the definition, it's also a YAML file. And it's quite similar. Not the same, but for example, here instead of on, it's called trigger. But you also have configuration, which branches should be included, which paths, which VM image you're going to use, and then we have a CI stage. On Azure DevOps, you also have the possibility to define stages. Stages are not available in GitHub Actions. And here's the same jobs: validate, what if, deploy. Looks a bit different because we don't have to use the Azure CLI directly. But the important thing is that if you're using Azure DevOps, it's not an excuse to not set up a pipeline for your infrastructure. It works as smoothly as on GitHub Actions. And the same, of course, goes for our web application. There's also a YAML file for that, compilation, deployment, and so on. And the second thing I want to show you is that Microsoft is working on a new domain-specific language for Azure Resource Manager templates. Because if you take a look at it, it's JSON, and this one is really small. It's just a website and now a storage account, but it's already 100 lines long. And as soon as you also define some functions, more variables, and more references between resources, the template gets really messy, and in my opinion, JSON it's better than XML, but it's still, I'm not completely happy with that. So that's why Microsoft is working on a new DSL. It's called BICEP or BICEP. Let me show you that. It's just a sneak peek. There is. There we go. So I have the same, exactly the same resources here in a bicep file. And as you already can see, it's much cleaner. If we compare it here, we have these parameters and this and that, and here it's much cleaner. We've just defined the param variables. We can work with string placeholders here. If you want to use the same prefixes, then we have our resources here. And what's really nice is that with bcep, you don't have to define the dependencies. Because, for example, if we take a look at the website, at our web app server, we have to specify the app service plan to the web app. And if you take a look at how it is in the ARM JSON, you have to specify the dependency here. And here it's just, you can define it like it's an object in your template. And what's pretty neat is that bicep will automatically build a dependency graph. So we don't have to specify the dependency for itself. As long as you specify it directly with the resource object here, it will create the graph automatically. So how bicep is working, it's another DSL, and there is a CLI, and this will just transpile this bicep syntax into an ARM template as JSON, and the pipeline looks pretty similar. So here is an example of a GitHub action pipeline when we want to use Azure bicep. It's all the same here. The only difference is that we now have one additional step, and there's an action to transpile the bicep file to a JSON file. And after that, you will work with the JSON file in your workflow as you would if you just have the ARM template and don't using bicep. All right, that's it. Thank you so much. And as mentioned in the beginning, if you're interested in infrastructure as a code, please also look at the different options like Terraform, Pulumi, or Farmer. And thank you very much, Manuel, for giving me this opportunity and for organizing this awesome user group.
Thank you, Manuel. You are very welcome. Thanks a lot for your session. So the floor is open now for questions. If there are any questions, feel free to ask them in the chat or by voice.